Welcome to Mechanical Zone. In this video we will discuss briefly about sensors. A sensor is a device that detects and measures physical phenomena of mechatronic system. Sensors are essential components in mechatronics, as they provide feedback to the system about the environment and the state of its components. Sensors are typically connected to a microcontroller or a computer that processes the electrical signals generated by the sensor and takes appropriate actions based on the measured values. Sensors are critical components in mechatronic systems, providing essential input for control and feedback loops, and enabling the system to interact with its environment in a precise and intelligent manner. While sensors and transducers are both used to detect and measure physical phenomena, there is a subtle difference between the two. A sensor is a device that converts a physical quantity, such as temperature or pressure, into an electrical signal that can be used by a mechatronic system. It typically uses a physical property, such as resistance or capacitance, to sense the input and convert it into an electrical signal. A transducer, on the other hand, is a device that converts energy from one form to another. It may convert a physical quantity, such as pressure or displacement, into an electrical signal, or it may convert an electrical signal into mechanical energy, such as motion or force. So, while a sensor is a type of transducer that converts a physical quantity into an electrical signal, not all transducers are sensors. For example, a speaker is a transducer that converts an electrical signal into mechanical vibrations that produce sound, but it is not a sensor. In summary, the main difference between sensors and transducers is that sensors specifically convert physical quantities into electrical signals, while transducers may convert energy from one form to another, including electrical signals. There are various types of sensors used in mechatronics, each with its own specific function and operating principle. Some common types of sensors include temperature sensors. These sensors measure temperature and are commonly used in HVAC systems, industrial control systems, and medical devices. Some examples include thermocouples. Pressure sensors. These sensors measure pressure, and are used in various applications such as industrial automation, aerospace, and automotive systems. Examples include piezoelectric sensors, capacitive sensors, and strain gauge sensors. Proximity sensors. These sensors detect the presence or absence of an object without physical contact, and are used in manufacturing, robotics, and automation. Examples include inductive sensors, ultrasonic sensors, and optical sensors. Accelerometers. These sensors measure acceleration or vibrations and are used in applications such as automotive safety systems, aerospace, and robotics. Examples include piezoelectric accelerometers. Gyroscopes. These sensors measure angular velocity or orientation and are used in navigation, robotics, and aerospace systems. Examples include mechanical gyroscopes, fiber optic gyroscopes, and MEMS gyroscopes. Magnetic sensors. These sensors measure magnetic fields and are used in applications such as navigation, automotive systems, and consumer electronics. Examples include Hall effect sensors and magnetoresistive sensors. Optical sensors. These sensors detect light and are used in various applications such as robotics, medical devices, and automotive systems. Examples include photodiodes, phototransistors, and optical encoders. Humidity sensors. These sensors measure the amount of moisture in the air, and are used in applications such as HVAC systems, food storage, and medical devices. Flow sensors. These sensors measure the flow rate of fluids or gases, and are used in applications such as industrial control systems, HVAC systems, and automotive systems. Examples include thermal flow sensors, mass flow sensors, and differential pressure flow sensors. Level sensors. These sensors detect the level of liquids or solids, and are used in applications such as chemical processing, food and beverage production, and water management systems. Examples include ultrasonic level sensors, capacitive level sensors, and float switches. pH sensors. These sensors measure the acidity or alkalinity of a solution, and are used in applications such as wastewater treatment, chemical processing, and food and beverage production. Force sensors. These sensors measure force or pressure, and are used in applications such as materials testing, robotics, and industrial control systems. Examples include piezoelectric sensors, strain gauge sensors, and load cells. Gas sensors. These sensors detect the presence or concentration of gases, and are used in applications such as air quality monitoring, industrial safety, and automotive emissions control. Examples include electrochemical gas sensors, infrared gas sensors, and semiconductor gas sensors. Tilt sensors. These sensors detect the orientation or angle of an object, and are used in applications such as construction equipment, robotics, and aerospace systems. Examples include MEMS tilt sensors and liquid level tilt switches. Sensors are widely used in industrial applications, and they play a critical role in many aspects of modern manufacturing, including automation, quality control, and safety. Some common industrial applications of sensors include process control. Sensors are used to monitor and control various industrial processes, such as temperature, pressure, and flow rate, ensuring that they operate within specified ranges. Quality control. Sensors are used to measure various parameters, such as dimensions, weight, and color, to ensure that products meet the required specifications. Predictive maintenance. Sensors are used to monitor the condition of machinery and equipment, detecting anomalies and predicting failures before they occur, allowing for proactive maintenance. Robotics. Sensors are used to enable robots to interact with their environment, detecting objects, measuring distances, and performing other tasks that require sensing and perception. Safety. Sensors are used to detect hazardous conditions, such as high temperatures, toxic gases, and vibrations, and to trigger alarms or shut down equipment if necessary. Energy management. Sensors are used to monitor and control energy consumption, helping to reduce waste and optimize energy efficiency. Logistics. Sensors are used to track and monitor goods throughout the supply chain, from manufacturing to distribution to delivery, providing real-time visibility and control. Overall, sensors are critical components in industrial systems, providing real-time data and feedback that enable efficient and safe operation. With the increasing adoption of automation and Industry 4.0 technologies, the demand for sensors is expected to continue to grow in the coming years. Thank you for watching.